Okay, so this is number 3. Okay, this is probably more the standard form that you're going to be used to seeing polynomials in. So this one we just want to find all the zeros, and we want to list the appropriate number of solutions counting multiplicities. So we're going to use the zero factor theorem. Remember how we listed, we took the last number, which is 36, the constant, and divided by all the factors of the leading coefficient, which is 1, to find all the possible zeros. So all the factors of 36, and remember plus or minus when we do this list. 1, 2, 3, 4, 6, and then not 8, 9, 12, 18, and 36. Okay, so all my pairs are 1 times 36, 2 and 18, 3 and 12, 4 times 9, and 6 times itself. So these are all the possible numbers. Again, it's a big list to try positive and negative. So what I recommend is using your calculator. We're going to actually graph this and look and see where does the graph cross. So go to y equal, and I'm going to type this in. So we're going to do x, which is next to the alpha button, and then raise it to the 5th power, so that's x to the 5th, and then plus 7x raised to the 4th, and then plus 19 x to the 3rd, alright, and then plus 37 x squared. We can just do the squared button here, and then plus 60x, and then plus 36. Alright, so we have all this in here. We're just going to hit graph, and we just want to see if we can see a few of them. Okay, so it looks like if I'm counting by ones, at 0 this is -1, and then that's -2, -3. So when it talked about the ones that flatten out, let me zoom in, see how far it zooms in so you can see that a little bit better. Zoom into that area right there. Okay, so when the graph turns around like that, that's what we consider a flatten out. And the fact that it touches like this means that we're going to get a double root. That means it's going to do twice. So this is -1, -2, -3. That's just my cursor blinking in the spot. So -1 is a 0, and then -3, we're actually going to try that one twice. So we're going to do -3 twice, and then we should have a linear, and we should be able to factor it from there to find the other ones, because they're not on screen. Alright, so I'm going to do synthetic division. Remember I said -1, and we're going to do -3. We're going to do that one twice. Okay, so starting with -1, and then listing all my coefficients. So the coefficient on x to the 5th is 1, and then we have 7, and then 19, and then 37, and then 60, and then 36. Alright, so with synthetic, we're going to bring the first term straight down, multiply, we get a -1, 6, we get a -6, and we get 13, and then -13, so I'm just multiplying, and then Subtracting, we get 24. Okay, and then negative 24, and we get a positive 36, and then times negative 1, we get a negative 36, and then that brings down 0. Okay, so the fact that it ends in 0 tells us that it is a 0. And then we will start with negative 3. So now we're going to use negative 3. So bring down the first term. And then multiply by negative 3. And we get positive 3 when we subtract. This gives us a negative 9. Negative 3 times that. And we get a positive 4. Gives us a negative 12. Gives us a positive 12. So a negative 36 when we multiply, and that ends up with 0. Okay? So we start out with the 5th degree. Once we divide off one, this is an x to the 4th degree. Now we divide off another one, this is an x to the 3rd power. And I'm just keeping track of this so that I know what my last one is. So I'm going to do negative 3 again. It was a double root because of that little U shape where it touched. So we're going to bring, again, the first number straight down. Multiply negative 3. This gives us 0. Times 0, that gives us 4. And then times negative 3 gives us a negative 12. And again, we get 0. Alright, so now this is an x squared function. So what we have left, this is 1x squared. This is 0x, and then just plus 4. So this is what we have left. Finding this, we're going to set this equal to 0 and just factor it, or it won't factor, so we'll just move the 4 over. So that will give us, and I'm running out of room here, so hold on. Alright, so moving the 4 over, that will give me x squared equals negative 4. And then if you take the square root of both sides, okay, not forgetting your plus or minus, we have x equals positive or negative 4i, or this will become 2i. So all of our zeros listed are negative 1, negative 3, and then we have positive 2i and negative 2i. And this wants us to find all zeros. Be sure to list the appropriate number, counting multiplicity using linear factor theorem. Okay, so I'm just going to list them, okay, which are negative 1, because they have curly brackets. We don't have to do them in parentheses. We're going to list negative 3. Even though it's a double root, we don't have to list it twice. Now we're going to do 2i. And then negative 2i.